We're looking at a methodology wherein if we have product of two functions and we are not able to do any substitution or any particular formula that we can use, we will end up using integration by parts. Now, the key idea which this is based on is product rule of derivative. That is uv, the differentiation of this is u prime v plus v prime u. So what is the procedure? Procedure is we have to classify the given, see there are two functions, is it not? It's a product of two functions. So we have to classify one of it as u of x and the other one as v of x. And then we have to compute, that is find the derivative of u and we have to integrate v. Then apply the integration by parts formula. So that would be over here. So the formula looks like this. So we have uv dx, so that would be u integration of v dx minus integration of u prime integration of v dx, closing the brackets, and dx. Basically something like this, right? Agree? Next. Oh yeah, then post this, simplify the resulting integral and evaluate if possible. Repeat the process or use other integration technique, so on and so forth. So this is the basic idea. I will give an example, only then it will make sense. Now, the very first step, I would like to go back to this, is to choose u and v, right? For example, here I have bunch of, well, 3 questions wherein I have two functions multiplying each other. So I have to classify one of them as u, another one as v. So which to classify as u and which to classify as v? See, we can see over here in the formula that v is the one which is getting integrated 2 times, while u is the one which is getting differentiated. So we have to choose u, right? So function that becomes simpler or reduces in complexity after differentiation. So that is the one which we have to choose. Commonsensical point. While v, or in this case v prime, so I'll call it as v only. So v would be the one wherein would be the one which makes it easy for us to integrate, right? So I have bunch of examples. Let's use this. So in this case, which should be u and which should be v? Think of all the 3 scenarios, pause and think of it. This is how you learn. Okay, let me start off with the first question. So it should be easy, or it should be reducing in complexity after differentiation. Obviously it has to be yes. So this has to be u of x and this will be v of x. Right? Next, between this, the tendency for us to pick up u of x as x squared plus 1 is high, but integrating log of x is something that we have not learnt. So in this case, it is log of x that we have to pick up. See, we have to look at both the ends. If I happen to pick up this as u of x, then the integration of the other function should be simpler. See, we don't know how to integrate log of x. So obviously, it's better for us to differentiate this and find the integral of this. How will the answer end? That you will get to understand when we do such questions. In this case, again in this case too, even though x is easy to differentiate, I have to take up sine inverse of x for the reason being, yes, it is not, we don't know the integral of sine inverse of x. Does it make sense? So it would go like this, but yeah, end of it, how is that this will get simplified? That we'll understand in time. Right, guys? Okay, so let me show an end-to-end example. So we have integration of x sine of x dx. I'm going to take u as x, and v as sine of x. Okay, now integration of, or I is equal to, so the formulas are over here. So we have f of x, instead of u I have used f of x, into integration of g of x dx. So that would be x into integration of, oh yeah, I didn't find out that. So we need to figure out d of x, sorry, d of u, which is dx in this case, and the integration of v dx will be minus cos of x. Okay, so this would be minus cos of x. Not writing the formula, let me actually write it off, makes it easier to understand. So we have u integration of v dx minus integration of, I'll open the brackets, u prime integration of v dx, and we have dx at the end. So this is clearly just x, and this is minus cos of x, agree, minus of integration of, so this is 1, and the integration of v dx was minus cos of x dx. So this is already simplified, there's nothing much we can do. Minus of minus is plus, remember this is into integration of cos of x dx, and finally minus x cos of x, integration of cos of x is plus sine of x, and then a constant. Technically a constant should arise here also, so plus k and then plus c, right? So this is how you handle integration by parts. So yes, it's important for us to remember this, and always remember you have to choose u of x, so that the other part practically we'll be able to integrate it. Like sine of x, it's easy to integrate, so I was able to choose u of x as x, right? Okay, so you can pause and copy all of this, don't miss anything.